Ram Prasad, sir. Open resource person slide, sir.
Prasad, sir.
Sir, I have changed it to resource person slide.
Okay.
Prasad, sir. Prasad, sir, are you there?
Yes, sir.
Prasad, sir.
Sir, I'm in online only, sir.
Prasad, are you there?
Yes, sir, I'm in online only. Your voice is audible only.
Hello. Am I audible?
Yes, sir, audible only, sir.
Okay, and my video is also working fine, right?
Hello. Priyatosh, sir.
Yes.
Yes, sir. Sir, you wait 2 3 minutes.
Sorry, your voice is unclear from my side. Can you repeat?
Priyatosh, sir.
Sorry. So my voice is clear, right, from your side? Hello.
Yes, sir, your voice is audible only, sir.
Okay. Okay, so I'm just going to share the screen and then I will open my PPT. So I think it's 1:55, so it's still 5 minutes there. So we will start exactly by 2. Is it fine?
Yes, sir. You can start the session at 2 o'clock.
Okay, okay. So I'm going to share my screen, and just after that, you will confirm that. So but how could I minimize the Zoom screen? Zoom ratio fit to window. Full screen. Yeah, that's fine. So now I have shared my PPT. So is it visible?
Sir, Priyatosh sir,
Yes, yes.
so you wait 2 minutes, sir.
Okay, okay. So should I stop the sharing?
No problem. Slides is okay. Just wait 2 minutes.
Okay. So, Professor, you may tell me when to start. So I have already shared the screen, and just after your instruction, I will start my session.
Sir, we will give up your introduction. Then after that, you can start.
Sure, sure. Okay.
Okay. So, dear partner, good afternoon. So, we will start the session. Now, I request Shivani Madam to give the introduction of the today's speaker.
Good afternoon to one and all. Hi, Arika Shivani, working as Assistant Professor in Triple Department, Lendi Institute of Engineering and Technology. Here, I extend my warm welcome to all professors, associate professors, and assistant professors for today's FDP on new trends in power electronics for microgrids and electric vehicle, organized by Triple Department, Lendi Institution of Engineering and Technology, and autonomous institution. I am honored here to introduce about today's resource person, Dr. Priyatosh Mahisar. He received MTech degree in Electrical Power Systems from the Birla Institution of Technology, Mishra, Ranchi, India in 2013, and the PhD degree in Electrical Power Systems Control from the Indian Institution of Technology, Kharagpur, India in 2021. He is currently working as an assistant professor with the School of Computing and Electrical Engineering, Indian Institution of Technology, Mandi, India. His research interests including smart grid operation, grid integration of renewable energy resource, and EV charging architecture. He was a recipient of the prestigious POSCO Power System Award 2022 for his doctoral research work. Thank you, sir.
Okay, so thank you for formality. Just I know that it's very means it's my opportunity also to get such a platform and to have a nice interaction with you all. So means from this introduction, the audiences. Okay, so anyway, I want to know one thing before starting the session, that what are the kind of audiences? Are they students, research students, or industrial people, or academicians? Hello?
Sir, you can continue, sir.
Yeah. So this is just a question from the from my side to the coordinators. So someone can answer me, because accordingly I will explain these things. So how will you means think that academicians are mostly there, or industrial peoples are also attended in this program?
So most of the people are from academics only, and
Okay.
some people are from industry also.
And are they mostly the PhD students, or maybe research students?
Yes, sir. Around 70% are PhD completed students.
Okay.
Assistant professor and professors also.
Correct.
Associate also is there.
Okay, so thank you for this information, because in any talk this is very important, as I feel that though these two things are very much related to each other, means academics and industry. However, in especially in our situation, in Indian situation, what we have realized, that industrial knowledge is not so much in parallelly flowing with the academic knowledge. Hence the research struggles. And in my time means it's not so fast, because I am also very much recently I have completed my PhD in the last 2 years. So what I feel personally, that we really encourage the industrial knowledge in research, in our even academic research, and these things are very much lagging in present situation in our country. So accordingly, I will discuss, and obviously this is just a 2-hour session, and we also feel that this 2-hour session cannot be explained thoroughly. So I will try to I will try to brief the things as much as possible, and audiences are encouraged to terminate me at any time and question if the coordinators permit. And other way is also that they are encouraged to have the questions in chat box or something, so the coordinators can tell me in between also if there are so many questions. Then I will stop for a few moments and I will try to answer all the questions. So I think, is it okay?
Okay, it's okay, sir.
Yeah. So now I'm not I'm just starting this talk immediately. So 1 second, just okay. And yeah, one more thing, that if suppose some communication issues are there in the meantime, then any of your organizer, if you have my contact, then please kindly call me immediately, so that I will know that the communication is already broken up. Okay.
Okay, sir. Okay, it's okay.
Yeah. Okay. So now is it full screen? So this content includes a lot actually, but I doubt that I can explain everything in this session. So it's starting by the trends, few very recent updates of electric vehicle related scenario, and it's mostly we will concentrate for our country, as we are Indian, so we should know that what is the present situation of our country in such an emerging topic, and then we will go to fundamentals, EV charging fundamentals, and then the converters. They are all most important part in our engineering, especially in the power electronics. However, I may not discuss this the third section in very detail, because I also understand that if the audiences are already in power electronics background or in master's course they had already completed, then many people will be interested to discuss more in this. However, I will just restrict myself in all these topics with the basics, because this is I think 2-hour session, so I cannot explain in detail. Okay, so that is why I will restrict this part little bit, and then EV charging station design, installations on design, and architecture. These 3 parts I will try to cover as much as possible, because these things are actually pretty important in industrial side. If you join any startup company or even a big company who are working on the EV side, they will ask you this type of several questions during interviews or even during working conditions. This knowledge is pretty much required. And but I also feel that these 3 things are these 3 topics are generally means underestimated when we discuss about engineering or technology knowledge in EV. So that is why I thought that these 3 things I can focus in this talk, and that will be useful for your future, especially in industries. Okay, but in academics, paper writing kind of thing, paper-based research, these things may not be required, because these are all well established and there are very few scopes to have some research in these installations part and architecture. Energy asset management, these 3 things are slightly towards the grid connections. Okay, so these energy and asset management, smart charging, and finally this last part is future perspective integration with renewable energy technology. So these 3 parts will be mostly covered towards the grid connections of EV charging stations. Okay, now as the in Indian situation, we are not very much immersed, or we are not very much famous in this EV technology, because in European countries they are far ahead. I have to say this because actually this is true that they are far ahead of us in this situation. However, if we think that government policy wise, government promotion wise, then I can say you that maybe after another 10 to 15 years we can compete with European countries, because our scale up, we are scaling up such a technology at a very fast rate. So you can see that this is not a very much historical thing. Just wait, I will make the laser view. So pointer options. Yeah. So you can see that this is just 2015. So it's not even so much historical thing I am showing you. And this is a very fast established policy which is being made by our government, and our Honorable Prime Minister is also promoting the EV technology, and that is why this policy has been established. So this is first phase. This is phase 1. That was 3 years plan, and around 4 years plan. So it was started by 2015, and this phase was being completed at 2019. So this 4 years, during these 4 years, we can see that it is named by a mission, because we have to be very fast to compete with other countries like in European countries and USA, of course. So now you see that in this 4 year, what we have made, I will just tell you in the next slides. Then after this first phase has been happened successfully, then government thought that it is possible to have a second phase implementation. So that was being started by exactly, this is a continuation. You can see that it's 1st April 2019 to presently ongoing. Okay, so it's now 2024, but still it's not a third phase. We are still in second phase. So first phase has been completed in very faster way, but in second phase is slightly slower. So we will also understand why it's so. Okay. Okay, so now you see, apart of FAME 1 and FAME 2, we have also several policies to incentivize the plan, because when government think about any new technology, any government will not so much interested about the insight of the engineering, right? So they are all politicians, and they will also think about the general people of the country. So how that will be beneficial for a common people. So when some government will make it policy, they will also understand that especially in the developing country like India, they will think that how we can make it cheaper so that people can access, most people will access it, and then you will see means expansion of the market, correct? So we all understand that in our country, this we are not so rich. Okay, so government always tries to make it cheaper. And also when some company will start to explore a new technology, then they will also have some issues in capital investment, correct? So in such a transition phase, there is a significant role from the government side. If government can help the company, and so that the customers will also get the benefit, then we can see the market will expand in a very faster way. So that is the point here. You can see production linked incentive. So this is completely an incentive plan design, and central means in very beginning time, like in 2015, central government was imposing this scheme to overall every state. However, later on, that government thought that why not it's distributed kind of thing, means state-wise policies. It means that it has been understood that in India, especially, the geographical proximity is much different from one state to other state, correct? So the access of EV technology will also be slightly different from one state to another state. Hence, these incentive plans should not be uniform for all the states. So that is why the centralized model was being converted to the distributed model. Hence, the state government had also an active role in such incentive schemes. So you can Google it also, PLI scheme, okay, and you can very easily get a draft of PLI schemes, how is it is modulated with time, and which states are presently following these schemes. It means that central government is not monitoring directly, it is indirectly helping to the customers through the state government policies. Okay. Now, you can see that about 50% of Indian states have state policies presently. Okay, this is also not very recent. I can tell you this is an update of last, there is no update of last 2 years. I don't have the update. Okay, and but in up to COVID time, means just post-COVID time, you can say 2021 till 2021, we have seen that around 50% of Indian states have state policies for promoting the use of EVs, and of course that will make benefited to the central government, of course. Okay. So the FAME phase 1 had an initial budget of 8,950 million, and that is the Indian rupee. And then the target was that a demand side incentive scheme that was completely centralized. Again and again, I'm telling you that this is very much means important to know that initially the FAME was implemented in a centralized manner, and incentive plans was being decided by completely central government, and that was 60% of total fund will be provided for only incentives with a focus on technology development. Infrastructure creations and boosting demand also was the part of this subsidy. Okay, so that is not only giving direct benefit to the customers, but it is also helping the startup companies. So that the pilot projects was being started, and it was very fastly growing. Electric and hybrid technologies, including mild hybrid, strong hybrid, plug-in hybrid, and battery based, of course, are covered under these policies. Then after another 4 years, when this phase was successful, government was thinking that phase 2 will be started, and you can see that the budget was very higher than FAME 1. Okay, it's much higher than this FAME 1 because FAME 1 was very much successful. So then you can see the incentive plans was also increased. It was 60%. Then government decided that it will be 86% going towards the demand incentives and 10% toward the development of charging infrastructure. Why is it so? Because in phase 1 there was no such big company, and also there was very much little foreign investment in this technology, especially in this country. And after this phase 1, when other country was looking into our country, that the customers are also willing to purchase such a car or 2-wheelers or 3-wheelers, then foreign investment was also started, and then actually progress came. Okay, so then this is the actually beauty, because if customers are increasing, then incentive plans are really works, correct? And infrastructure, once it was made or established, then infrastructure requirement is also not so high. Initially it will be very higher, and then slowly it will be saturated. That is why initially government was helping more in the infrastructure side. Later on it was being reduced and it was being shifted towards customer benefit. This phase was also targeting 7,000 electric buses, 55,000 four-wheel passengers vehicles, and mostly it was being targeting towards 3-wheel vehicles and 2-wheel vehicles. So 3-wheel vehicles mostly you can see in our road, okay, and these are well established presently, and people are happy also. So now the charging stations. So charging stations in phase 1 was not so much invested, but in phase 2 it was being required, because in the large scale, when the EV technology was being implemented, then it is not possible that you will always charge it in your home, because mostly our country is a developing country, and we cannot expect that every household people will have their infrastructure to charge their own vehicle, correct? So that is why this policy was thinking, this FAME 2 was supporting the 2,700 charging stations in especially large cities. And initially it was started by only metro cities, then slowly it was being planned to other cities as well. Now, another thing, that how could we make standard policy for the charging stations? because in FEM 1 there was no such standardization for charging station. Means what should be the ideal size of the charging station, and how much distance wise we can establish the charging stations, what should be the capacity of the charging station. So many things was coming to the means doubtful. It was doubtful, and it was a big problem for the customers that to manage their own vehicles without knowing the charging capacity of the charging stations, correct? Because that time people were investing in the charging stations, but that performance was not satisfactory. To make it satisfactory, government must make some rules or some policy to manage it in a better way. So now state government policies, as I told you, that over 14 of India's 28 states had finalized or are in the process of finalizing EV policies that supports the national electric mobility policies. That is a phase 1 and phase 2. So you can see that the states Andhra, Karnataka, Kerala, Madhya Pradesh, Maharashtra, New Delhi, Tamil Nadu, Telangana, Uttarakhand, and Uttar Pradesh. And also you can see that that Bihar, Gujarat, Himachal Pradesh, and Punjab are among the states with draft policies. It is, again, I'm saying it is 2 years back update. So presently, I know that Himachal Pradesh has already implemented this thing, okay? But other states I'm not aware of. So you may search in Google and you may find. So this is the extended PLI scheme implemented at November 2020. And 4 to 6% incentive was provided to eligible companies. Eligibility again depends on the sustainability of the companies, okay, and their sales. So we all know that during COVID time, the startup companies was very much affected, especially these type of technologies, right? Because there was no such cars and vehicles were operating on the road, so they were really struggling. And that time actually the incentives was very much requirement to make it sustained. The small companies should be sustained, otherwise it could be closed. And post-COVID situations, it could not be means reborn, you can say, right? So that is why you can see that the 4 to 6% incentive is, I think, very much higher side in the government, because in other technology they actually don't give so much incentives, especially in the startup companies, correct? So 4 to 6% incentive was provided to eligible companies, and in these eligible companies you can find in Google also, they were mostly the startup companies. They are mostly the startup companies for a period of 5 years after the base year. So on November 11, 2020, the PLI scheme was extended to 10 additional sectors. Okay, so that was completely the COVID time. So that is why it was being extended. And in this major push for EV vehicles, the PLI scheme for advanced chemistry cell battery manufacturing was also approved on November 11, 2020. However, another challenge was being made that what about the battery cost? Should it be incentivized separately? Because we have understood that the EVs cost are mostly regulated or controlled by the batteries. So batteries could be incentivized separately, or it would be overall incentivized by the government. Means vehicle should be incentivized, or battery separate incentive plan should be there. Okay, so this thing was again another thought from the government side. Manufacturers that achieve 60% value added within 5 years of project commencement will be eligible for the subsidy. So this point has been made from the government that those who are successful in this technology, they will only get the 60% additional value. Okay, so that they will again grow in a faster way. Then another policy, the vehicle scrappage policy, was announced in the Union Budget in February 2021. It aims to reduce India's oil import through greater deployment of new fuel-efficient vehicles. And in this regard, I should tell you one statement that those who are listening to my talk, you should think that why EV is very, very important in the present situation. I understand all the emerging technologies are important, like solar, wind, everything. But why EVs should be looking into separately? Because only this statement you can take it in a separate way, that we all understand that our economy mostly depends on oil imports, correct? Because our present situation still demands a lot of oil, crude oil from outside the country, and that is why it is important to reduce the import as much as possible. How is it possible? There can be several ways, but one very important. Sorry, anybody is asking anything? Hello?
No, sir. You can continue, sir.
Okay, okay. So you can see that if we can reduce the oil import in a different way, then obviously our economy will be stronger, correct? So that is why I suggest all of you that there are many such emerging technologies coming up in this Indian market. However, electric vehicles are something different. We should take a special care of this immediately, because this is the right time to think of these EVs to reduce the import of oil from outside. Like you have seen also that in any geopolitical situation like Ukraine-Russia situation, or presently the Iran's situation, always our economy affects, right? Because of only the dependency of this crude oil, because this crude oil price is very much dependent on the geopolitics. So if we could be independent, it's not possible immediately to make it independent. It's not also possible that it's only depending on EVs. I understand, but EV has a significant role to reduce import oil from outside, correct? It's not for only pollution. People generally misunderstand that to reduce the pollution, we should think about EV. Then the consecutive questions comes that why only EV? Then solar, wind, any renewable, sustainable resources will obviously reduce the pollutions. But why then EV is more important than other technologies? Answer is this one, that it will reduce your oil significantly, which may not be the case of the other sources or other renewables requirement in India. Because in Indian situation, the demand is also much higher than other country. Okay, so this is slightly just one slide I have provided you to know that presently where we are lying. Okay, so this is the futuristic plan being made by most country in the world, and in the color code you can see that this red or pink color, this is the pink color, or deep pink or light pink. Okay, so deep pink are very much emerged, actually they are very much developed in this EV technology. So you can see they are targeting 2030 only, means just 6 years. After 6 years they are trying to make 100% battery based and fuel cell based or hybrid electric vehicles. Okay, but in the light pink colors they are targeting 5 years more. Okay, But you can see Indian situation. Indian situation is nowhere that they can compete with these countries. Okay. So you can see that, and you see that European countries are far ahead than the USA, because you see color, they are targeting 2025. It means they are already achieved their target. Okay, they are already mostly achieved their target, 100% BEV and fuel cell based electric vehicles. Okay. However, in India, they are targeting actually 2050. Okay, so we are not here to compete. We are only here to understand this situation, that how much we have to progress. At the same time, we also should understand we should not be demoralized. You should not take this slide that in our country I'm showing you the negative thing, because to know that how much progress we should make. Of course, each and every country has their own politics, their own size, their own GDP per capita. Many things are coming into the picture. So we should not look into only that this country has been made so much, it means they are much developed than us. We should not think about this, because we are having population pretty larger as compared to other country. Don't forget this. So when our government think and decide something, it is much more stressful than other country. Correct? So obviously, when you can compare that a bigger machine, when we start, it should start with a slower pace. Correct? But a smaller machine, small machines can immediately start and immediately stop. So that is the case. In Indian situation, we are having a bigger population. So we have already started and we are growing in slower pace. So that is the situation. Now you see that this graph, okay, and this plot showing clearly that how with the time wise, you see mostly in global scenario, if you see that no country were getting interested, or you can say you can think that they were understood the importance of the EV technology before after 2018, you can see, because you see first 2015, before 2015 there was negligible contribution on any country. So all these countries were expanding their investment on this technology. However, the China, Europe, and North America is pretty faster as compared to rest of the world. So this is a slope how it's increasing their investment in their own country. And of course, we are not including the foreign investment in this part. Remember, this is actually the EV annual sales will reach 32.1 million units in 2030. So this is actually sale of means customers' interest, you can say. Okay, customers' interest, you can see. That is why I'm saying you that in this regard, in Indian situation, you may not see it here, but after another 5 years, you may see we may overcome all the country, only because that we are having a huge population. Number of sales will boom once foreign investment will start. However, we are lagging behind their countries because the foreign investment is not so much reliable. That is why government should reduce the taxes of the investments, foreign investments, and that is why this is challenging in present situation. So I'm skipping this because these are all data, okay, and they are very similar data. So this is the cumulative annual growth rate, and any company, when they start their things, their installations, or they start to business, This is very, very important. They think always how much revenue they can get and how much growth they can make, right? So you can see that CAGR is a very important factor for any investor side or any capital side. Okay. So investors also think that I am investing something, so how much return I can get. So of course, this parameter they will look into. So in 2020, it was being pretty less because during the COVID time, there was a several negative impact on this EV technology. And then it was just starting with a good rate. Okay. And mostly, as I told you earlier, also you have seen in the data that US, Europe, and China are dominating over the other countries in the present situation. Now, slightly technical things we will go through. So these things are not only component which you should think about. There are many more components are assembled to each other, and so this is complex. Okay, because most complex thing is the battery chemistry. Okay, when you will design any EV system, you should understand that which battery you are implementing there, and or fuel cell or something else, and what is the chemistry of that battery. So that is still there, that is the challenge. When we do some academic research, I have seen in many cases that we neglect the battery response in our converter side or even machine drives side. So when we say about time constant, let's say in machines time constant, then we completely decouple it with the battery. However, the machines, when they will coupled with this EV technology, then we should understand that how the battery's response will affect the parameters of the machines. So we should re-simulate the battery's design. Okay, so that is the challenge of EV technology. And these things, onboard charger, I will discuss in the next slides. Now you see these are the relation between several blocks. Battery cooling system is part of BMS, battery management system. Then the traction battery pack, this is very much related to the machine and drives. Power distribution, DC bus, this is when you will basically charge your battery. This is very much important to know that at what voltage level you should charge. I will also come into detail about this. Okay, and yeah, traction cooling system, this is also an important part to have the design, but mostly mechanical people will be interested in this. Okay, so that is why I will not discuss it in detail. So I understand the DC-DC converter, as I earlier told you, this is a power electronics part and people generally being interested in this. However, these are all important, and in every component there is their own research domain. So why high voltage? That is again one common question I have seen in the researchers, especially the beginners, that in the traction we generally think about the low voltage high current operation, but in EVs why we say about this 400 volt or 3-phase or even 230 volt system in the single phase. Only thing is that you can see these basic equations, then you will slightly understand my question. This P equal to VI, correct? And torque depends on flux, correct? And flux is proportional to this applied voltage. So higher voltage, it means more and more flux density. will also increase. Now you see that if generally flux is being increased, then we can understand that your torque will also increase. So because T proportional to phi1, phi2, so the higher torque requires the high voltage. Of course, we know that high current is generating the higher torque. As we know from the machine drives, normally we understand that high current, it means high torque, but we should not forget that flux has also an important role to increase the torque. And this flux will be only being achieved by the higher voltage side. Okay. Now we see these things. I will come again in the later things if time permits. So yeah, one more thing, that why pre-charge? This is also the common question from the beginners, that before connecting the EVs, okay, EVs to the charging stations, why we should make some pre-charging of the batteries, or suppose we should not make completely discharged condition of any EVs before making it plugged in with the chargers. So this is the two type of questions may come, that why we should not discharge our own vehicle completely before charging it again. So these things could be understood from batteries point of view, from complete vehicles point of view. Means you can see that this is the battery. We have just taken an example, 300 volt, and this is very high voltage, right? As compared when we see as a machine drives, generally 300 volt is pretty higher side. And you see that there are several contactor, but this is very, very important, active discharge resistor, and another thing is the pre-charge contactor. So this pre-charge contactor, actually when is being closed condition, you can see the main contactor will be open. So normally open and normally closed, NONC is being communicated to each other. And these two, don't think that they are all physical resistors. Presently, they are all power electronic switches. Okay, it is just a view to understand that what is happening inside. So it's duty being given to it, and it's very much fast control operation. Okay, but it generally happens in a complementary way. When it closes, it opens. When it closes, this one opens. Okay, so there are, when this path is closed, this resistance is being implemented in this path so that current reduces. Okay, because voltage is less, initially the voltage cannot build up because it's very much discharged condition. This battery is being discharged condition, and initially the dV/dt will be very high, hence the I will be very high. So to limit the current, this resistor is very much required. Otherwise, what will happen, I'm telling you, on every battery there are protective equipments to protect the battery. Okay, because some heating issues could be happen, some different problems can be happen. I will also come if time permits. It's a part of battery management system. So that protective equipments will be activated if the initial current is very high. So to restrict, this is very much required to restrict that current when you will plug in your battery in the charging systems. And again, I should tell you one more important thing. You should note it down also, that there are different capacity of the charging. So onboard, offboard chargers obviously is there, and there are different capacity of the chargers. So if charger itself permits the higher side of current, then again this is a more challenging thing than the low capacity chargers. Okay, because charger themselves has their own protective equipments. They cannot allow more current than their own capacity. So if that charger is eligible to be applied for fast charging, let's say, then this resistor has a very, very significant role to protect this battery. Okay. So you can see that how much high current can initially flow. You see 2000 to 6000 amperes. This is normally we see it as a means normally in transmission system we generally see this type of current or in fault situation, but not ever in such a 400 volt situation. So now you understand that this much of current cannot be handled with the batteries, right? Immediately battery will blow. So you see that this is again one just very basic connection, that high voltage battery. This is connected with a control unit, vehicle control unit. It's there. So this vehicle control unit includes the battery management system as well. Okay, and thermal management system also. These two things are very important part of this VCU. Then charging system controller will directly relate to the rectifiers and DC-DC converters. So now what type of chargers we can see? You see there are many type of chargers, and in these examples you may find that few charger models are still not in use in our country. Okay, and why this is not made, I don't have the answer, but maybe they will also be implemented in future. So I have not presently, I don't have the answer. So you see that this is typified by different category. There are mostly 4 types of connector. They are all means either single phase or 3 phase. Okay, so single phase are mostly used in domestic purpose, but in 3 phase they are required the charging stations mostly. Okay, now type 1 connector is this one. You can see that there are 3 main points, big pins you can see, right, and 2 smaller pins are there. So these bigger pins are, one is phase, one is neutral, one is ground. I cannot say which one is phase, which one is ground, so that could be position could be changed, but these 3 are actually signifying that phase, neutral and ground. Okay, and phase means this is the single phase. These 2 are smaller, these 2 are mostly used for the communication purpose. Okay, so these 2 are mostly not related to the direct charging purpose. They are all mostly regulating the different aspects, maybe smart charging and all. So they are, and also these two are related to the high voltage interlocking, HVIL. You may search in Google also that HVIL are pretty much used in single phase charger and 3 phase chargers to protect the human, when it is specially to protect the user actually. Okay, when they will keep their hand on the charger, generally high current starts to flow, as we have seen earlier, and if that being allowed in the human body, then you understand what will happen, correct? So that is why HVIL, high voltage interlocking protection unit, is being related to these 2 also. So these 3 points are important because this is a single phase charging, and you can see it can deliver 3 to 7.4 kilowatt and supports single phase with maximum 32 ampere. Though it says maximum 32 ampere, but very much standardization has been made in Indian situation. This is single phase charging should not be more than 16 ampere. Okay, this is again 16 ampere is being presently restricted in our country. Now you see type 2 connector is used with AC charging stations. So here you can see it is a 3-phase charger, hence 2 more big pins. Okay, previously it was 3 pins like this, another 2 pin is placed here. So you can see this is maybe phase A, this is phase B, this is phase C. Any one of these two may be neutral or otherwise ground. Okay, and these two are very similar. These are all already there in the single phase chargers. Now, as they are three-phase system, so their power requirement should be slightly higher, right? 43 kilowatts. So previously we have seen 7 point something kilowatt being restricted. Now we can go towards higher power requirement in the three-phase charging. This is actually not used presently in India, or very recently is being used in DC fast charging. Still, we are not so much established in this because very limited application is being made for DC fast chargers, and that is on highways. Okay, but that is very limited. Again, I am telling. But in Japan, they are very much ahead of us, and they are very much popular in using DC charging stations. Hence, they had implemented these chargers. And you see, this is a Japanese language, okay, and this means that you can charge your vehicle within that time where 1 cup of tea you can complete. Means you will have a tea while the car is charging. It means just you take a tea break. At that break time, you can have your own vehicle in charging conditions, and your vehicle will be charged. Means it is so fast. Okay, and initially Toyota, Mitsubishi, Nissan, these companies were very much established in EVs. Okay, but you may be curious to know why not Tesla, because Tesla was not implementing the high power DC charging applications till now. Okay, though they are very much established, but these Toyota, Mitsubishi and Nissan are actually making the DC they are actually interested to have the fast charging of their vehicles. You see that 62.5 kilowatt it can deliver. This power is very high, and that is why you need fast charging, right? The power requirement is less, then you may not be interested to have fast charging. And it can reach up to 125 amp. That is very, very high. This is again another type of charger. Okay, and you can see this power requirement is also not requirement. I can say that it can allow up to 350 kilowatt. This is CCS combo 1, and this is another type, CCS combo 2. That is also very similar. Only CCS combo 1 is single phase, CCS combo 2 is 3 phase. You can see by these pins. So difference between this combo and the previous model was that the previous chargers were specific to AC or DC. But these combo chargers are actually capable to charge both in AC and DC. Okay, that is why it says the combo. Now you see that these 4 modes were being made. Okay, and by the international standards 61851. Okay, that is actually being requirement to implement the charging stations, and government will not allow you if you are not showing this standard. So in this standard there are many things. A significant part of the standard is being explained for the protective units like surge protecting devices, RCDs, okay, RDDs. So there are several protective equipments. We will also explain a little bit, and these should be following the standard. Now you see these modes are actually initial 3 modes are for AC, and this mode 4 is only for DC. And this mode 1 is very much low power application. Mode 1 and mode 2 both. Mode 1 doesn't have any protective equipments, I should tell you. Mode 2 has their own protective equipments. Mode 3 is also having the protective equipments, and the charging stations are mostly applicable in this mode 3. This mode 1 and mode 2 are mostly in the domestic side. It means that you can use your own home infrastructure. Maybe you can take help from means any engineer or any local subdivision of the electric utility. So they can come, they can see your home conditions. They may suggest you that your home will permit this type of infrastructure or not. So you may take their suggestions. However, this modes doesn't allow you to establish charging station in your own area. Okay. So if you want that you will start a business in your own home, it is not allowed in the present situation. So these three things are very much popular in the present Indian situation. However, this mode 4 is slightly being started in last 1 or 2 years, but it's not well established. Now you see that mode 1, as I earlier told you, that it is in smaller scale and you can easily use it to charge your own smaller vehicle. It restricts 16 amp only. It's and also when I'm saying it, this is typically for the Indian situation. Okay, because this 230 volt, you understand, this is also in Indian application, right? Because in USA it will completely different. Okay, so 16 amp 250 volt, you can see generally we say that 220 to 230 volt, it allows slightly higher voltage, correct? So that is the requirement of these charging stations, or you can say it's a charging infrastructure, that you should operate it in slightly higher voltage side in this single phase. And 16 ampere and 480 volt AC for 3-phase installation according to this IEC standard. So it is not still implemented. I'm saying you that this is not even implemented, but it is very sooner going to implement in mode 1 only. Okay, it means you will be allowed to have 3-phase system, 3-phase charging in your own home ground. Okay. Now you see that this is 250 volt AC, current is little bit higher, 32 amp, correct? But again, I'm saying that these modes are also very much presently in present condition, this is being very limited use. Okay, 480 volt AC 32 amp is still there, but 250 volt AC 32 amp application wise it is very limited, because it needs a very robust protective equipments to save the humankind or users. Now you see the mode 3 charging stations are being implemented, and most importantly, this power, you can see they are significant different than the mode 1 and mode 2. Okay, means high power vehicles you cannot be allowed to charge in your own home area. You have to connect it to the charging stations. Now in mode 4, this is the DC fast charging. It's mostly applicable in highways, especially of the EV trucks kind of thing or EV buses. And they are very high power applications and they need fast charging, because otherwise to make it full charge, they may require for a whole day, correct? So that is why when our country will see that the people or customers are very much interested to use the EV public transit, and government will make some incentive plans for such a heavy vehicles, EV heavy vehicles, then only this DC fast charger requirements will be expanded. Otherwise, these chargers are not required to charge your own two-wheeler or even three-wheelers. So in the present situation of India, you may find very less number of electric vehicles which are public transit like buses or trucks kind of thing. Okay, so but we expect that in next 5 to 10 years we will also see a much more DC fast charger than the AC chargers, and that is why this is again another research topic to have the grid connection of these DC fast chargers, how they will impact your active distribution systems. Now, this is the charging, means this is required. This slide is typically for designing your chargers or compatibility between charger and your vehicles. Okay, so you see that this charge time is generally depending on this battery capacity by charging power. However, this battery capacity is completely depends on your vehicles. Okay, because you are purchasing your own vehicle and the company itself designs their battery capacity, correct? However, your charger is where it is nowhere related with the company. You are purchasing a vehicle, you need to charge it. Should you ask your company that I should purchase your vehicle or not because I don't have this capacity of charger? That is not a way, right? As a customer, you will always think that I should be beneficial in both ways, that I should have a good vehicle and I should have my own charging facility. So that is why the charger design is very much critical. That should support a general type of batteries which are being used in the electric vehicles. So now you see that this charging power is actually minimum of EV onboard charge rate and charging station delivery rate. So whichever is minimum among these two, that will be considered. Okay, so these are a few examples. You can see that 40 kilowatt hour battery set. So this is very high, correct? This is very large vehicle you can imagine. Okay, it's not a like two-wheeler thing. Okay, so this battery set, when we will use in any vehicle, how could we charge it? Let's say you are having a 6.6 kilowatt onboard charger for AC charging. Okay, so now you see that this 11-hour from home charging station, as you know that this is a mode 1. Mode 1 will allow you 3.7 kilowatt maximum. I have just considered here for an example 3.7 to 3.7 kilowatt, let's say, and 3.7 kilowatt 40 kilowatt hour. Now it will compare to this onboard charger, correct? So onboard charger will allow up to 6.6 kilowatt. So 3.7 kilowatt is lesser than this one. That is why we should allow 3.7 kilowatt only, because this equation, you see which one is minimum among these two. So 3.7 and 6.6, which one is minimum? 3.7 is minimum. So that is why 40 kilowatt hour by 3.7 kilowatt, and that answer will be around 11 hours. Okay, so you understand that bigger vehicles, if you use them to charge in your own home, that will take an absurd time. 11 hours you cannot make it charge, right? So when will you use this? If you regularly use 11 hours for charging, then how will you use them? Correct? So you see here that, let's say, AC charging station for 11 kilowatt. Okay, so this 11 kilowatt charging stations is allowing 11 kilowatt, but your onboard charger in your vehicle, it is allowing not more than 6.6 kilowatt. So again, it will restrict to 6.6 kilowatt. Okay, So that is why 40 by 6.6, it is around 6.5 hours. Okay, now DC fast chargings are obviously very faster. They can use the full capacity of the charging stations. That is the beauty of DC fast chargers. Okay, they will use the full capacity of the charging station. So if charging station is 50 kilowatt, you can see straightforward, you can use this capacity. And 40 by 50 means only 50 minutes. So you see, if you charge it in your home, it will take 11 hours. But if you use DC fast charging stations, it will only take 50 minutes. DC ultra fast charging stations will only take the 10 minutes. Okay. And in this type of stations, the connectors, as I earlier told you, that is separate, which is presently being used in Japan. So this is again the same thing, that how it will impact the different charging infrastructure or charging architecture will impact your vehicle and charging time. So here you see that percentage of charge reached in 30 minutes. Okay, so this is initial charge, you can say 3%. Okay, and initial SOC also you can say, and 18 hours it takes if you are using your domestic charger. If you use slightly higher capacity of charger, it will again reduce the time. However, if you use the fast charger, you see there 100% charging within only 20 minutes. Okay, and you see that these are all mostly employed in highway side because they are only being used for high size of heavy electric vehicles. So I'm switching this because time already is 1 hour over. So till now, any question, if it's there, then I may clarify. So professors, if anybody can help me, that if any question in the chat box or somewhere.
In chat box, there is no question, sir.
Okay, okay. So dear audience, you are always encouraged to ask me question. Okay, I don't actually prefer.
At the end of session, we can ask the questions, sir.
Yes. Should we continue or should we break?
Continue, sir. Continue, sir.
Okay, okay. Now you see here that previously everything we were telling about electrical side, however, it's not only electrical thing. There are several things like mechanical aspects, communications, EMCs. EMCs are very much required to protect your device from the moistures, from the soil, atmosphere, temperature, ambient temperature, these things. Okay. And EMC is actually impacting your battery chemistry as well. This has been identified in papers that EMC is actually pretty much required to understand when we use the batteries. Presently, this EMC performance is only being implemented in mode 3 and mode 4. It means if you are going for the charging stations. But if you are preferring your small vehicle and to charge it in your home area, then these things are not required. And one important reason behind this is mostly your home. When you prefer to charge your vehicle in your home, you must have one garage or kind of thing so that this garage is well regulated, correct? At least as compared to the open area of charging stations. Generally, you just imagine in Rajasthan area, how much temperature differences being made, right? From daytime to nighttime. However, in your home, you must have some regulations of the temperature. So that is the thing that EMC affects much significantly, more significantly to the batteries, chemistries, and also chargers in case of charging stations as compared to the domestic chargers. So that is why I'm saying it's installed in indoors or outdoors. So indoor requirement, EMC is not so much important in indoor requirements. However, outdoor requirements are there. These are all protection standards. Of course, the IEC 61851 is looking over all around, but specifically if you are concerned or you are a protection engineer, then you should look into this IP54 and IP44. Okay, these two standards recommends specially that what should be your protective requirements, what should be the protective devices, what should be the placement of protective devices in your own indoor or outdoor charging installations. Now you see that altitude is also another impacting factor. As I earlier told you, that's why government was thinking about state-wise policies. You see that altitude and temperature, these two things are getting important parameter to have EV performances. In Himachal, actually, you may not like the low power applications, okay, because it's a terrain area and low power vehicles performance are not so good. However, in plain area like in Kolkata, you may find that smaller electric vehicles are much better than the heavy vehicles, correct? Because they are very rush in road, very rush are there. So small vehicles will be very much effective in Kolkata. However, it's not the case of in Himachal Pradesh. So that is why the incentive plans, as I earlier told you previously, it cannot be generalized. It should be generalized on the basis of customers' interest. It should be having thoughtful implementation based on the geographic proximity and many more things. In practice, charging stations can usually operate within a range of -30°C to +50°C. This is again I'm saying for charging stations, okay? And within a relative humidity range of 5% to 95%. And this is being regulated by whom? By IEC 61851 standards. Okay, the standard only says this range should be allowed. Okay, now there are few protective devices you should be familiar of. If you know, then it's well. Otherwise, you should understand these things and why they are required. So there are RC means RDC, DD, and there are RCDs means residual current detecting devices. Okay, residual current detecting devices are very much important because they are actually making isolation from your home. Means if you are connecting it in your home area, then only I'm saying that from your home to the vehicle. And also in charging stations, because charging stations are little bit high power requirement, that is why RCDs are more important in that case. Okay, RDC DD will also important, means DC chargers. When we say, then RDC is more important, but in AC chargers also they can connect this type of detecting devices. We will see the placement of these things in the next slides. Okay, so these things I can skip because time is limited. And okay, now you see this slide, the placement of RCDs and RDC DD. Means you cannot see if you are increasing the number of protecting devices, of course, your equipment will be more robust. There is no doubt on it. But what about the cost? Correct? You should, this is a foolish decision that you are using more than your requirement, right? So that is why the optimal placement of such a protecting devices are required. So now you see that, let's say your vehicle is connected in a charging station like this. Okay, this is the downstream, and this side, back side, you are having grid or it's isolated. It's not the not having any difference. That is why I have not shown in the back side what is there. But you can understand that if grid is connected, then grid may regulate many things, which is a problem, which can create a problem to operate such charging stations. But grid can be beneficial as well. So we will also discuss it in the very last stage of our today's talk. Okay, but now you just ignore that what is there in the back end of this charging station. Now you see here, first we have connected RCD type B, which is allowing 30 milliampere maximum current. Okay, if the current is more than this, it will detect a fault or any abnormal situation and it will open, so that this your device will be protected. And this contactor would be part of the charger. It's an onboard charger, then it's okay. If it is charging stations part, then you can see the dotted line should be extended towards this. Okay, so I have considered this is an onboard charger, so the box, the contactor is outside of this box. Okay, so I expect that you understand this onboard charger and offboard charger. If you don't understand, please mention it in the chat box. Okay, I will discuss it at the end. Now you see here that a different type is connected, type A or F. Current wise, that is also very similar, 30 milliamp, but it requires additional protective devices, RDC/DD. Now, of course, you will challenge me that why we are using additional detecting devices if this is self-sufficient. Answer is that more reliability. The reliability will be more in sense of that if your this RCD fails, then this will at least operate. Okay, so more reliability, it means it's a good thing that your device will have a less chance to have a failure. Okay, so that is why people generally prefers this type A or F more than this type B, because this type B is not having any significance to connect this RDC/DD. However, this type A or F is actually allowing this RDC/DD. So these things I will skip. Okay, so another thing you see. Now you see this is actually connecting RCDs in series here. It means there are several charging stations.
Excuse me, sir.
Yes.
Sir, one participant is asking question in chat box.
Yes, tell me.
Once again on board charging off.
Yeah, yes. So good question. So people actually generally being confused that onboard charger. So that's okay. So I have to go to here. That onboard charger is actually, you will see that chargers could be made separately from the vehicle. Okay, if it is included in the vehicle, then it is a one type. Okay, onboard charger. If you are separating it from the vehicle, then you may think it as a off-board charger. Okay, so onboard chargers are actually, which one is good or which one is bad, there is slightly means trade-off, we can say, but this is the main factor to know that onboard charger always restricts the vehicle to have a fast charging, because onboard charger generally limits the current. Okay, they cannot allow you in the very higher current, so that you cannot allow your vehicle to be fast charged. Okay, but off-board chargers generally are more flexible, you can say, that they can having a larger range than the onboard chargers. Okay, so if you are having any following question, then you can tell me.
One more question, sir.
Yes.
EMC, EMI effect on EV station.
Yeah, question.
EMC, EMI effect of EV station.
Okay. So I think that EMC requirement, I don't have the present slide, but as the question is being asked, I will answer you very briefly that humidity is a very impacting factor. Okay, humidity actually degrades the batteries as well as the chargers. So that will impact on the EMC. Okay, temperature will also impact on this, but temperature mostly affects the battery's performance, not like humidity. Humidity affects both the batteries and the charger performances, but temperature doesn't affect much on the chargers, because in the charging stations they are having their own arrangement to protect their own charging stations, okay, from the temperatures. So that is why this is actually requirement from the vehicle side, that the temperature must be regulated. So any other questions?
No questions, sir. You can continue.
Okay. So you see here that this is the series, upstream series. So you may find that multiple charging stations, okay, connected in series. Here actually you may imagine multiple loads. Loads means EVs. Okay, EV vehicles are connected in parallel. Okay, and this is another point. Okay, and this is also in parallel. Now, as I earlier told you that two types of RCDs we can use. One is RCD type B, another is RCD type A or F with RDC-DD. So these two types we will compare that which one is better and which one is not. So you see here that as 30 milliamp is there, so let's say two are in parallel, so we are allowing up to 60 milliamp. It may be 2, 3, 4, we don't know, but at least two should be in parallel. That is why I have written here that up to 60 milliamp. Understood? Means parallel means at least two should be there, correct? So at least two it is there, then up to 60 milliamp. If you are having 3, 4 more parallel connections, then you have to make RCD, more number of RCDs, correct, to make healthy operations. Otherwise, what will happen when you are connecting multiple EVs simultaneously? The RCD will detect a fault and it will trip from this point. Okay, so that is why this RCD, number of RCDs, how many you require, that always depends on what is your off-board charger's requirement. It means that you don't know, see, this is the design of the charging station, correct? You don't know that what type of vehicle will come in this point to charge, right? So you may have a high power vehicle, you may have a small vehicle, because this is after all a charging station. But how will you design this? So you will just satisfy your own requirement that this much of current I should allow. So let's say IDC, your capacity is 60 milliamp. So you know this capacity, And when one car will come to you for the charging, you will know that, because car owner will not have any issue. They will only say that I need to have charge within this time. I have this much of time. I am parking my car to your station. This is your responsibility to make it charged. And that is why I will pay you. Correct? So now the charging station owner or their employees will think that how they will manage this. So there are so many points. You can see parallel points. There are few parallel points. There are few parallel points. They will find that they may see that when your car is coming, they will see that where at which point the car will be connected. If this will be connected in here or it will be connected in some other place. They will see their own smart meters or some own sensors will be there. They will see that presently how much current it's drawing from here. And if that current permits, it means it is less than its allowable current, then only they will allow the additional car to be connected in this point. Okay, so that is the very basic way of management, you can say. Now, overall current will be dragged from the grid or any separate source. So here also one protective devices will be given. Now a simple question will be there that what should be the capacity or what should be the allowable range of this RCD? Of course, this will be more than this, correct? This will be more than this. So you could have a multiple parallel connection also if you want. And if you think that it's sufficient to have in series, then it's okay. So that is the way. And now you see here that if you connect this one, okay, this RCD type A or F. No, okay, so I just missed one point, that if you connect type B, then this side you see that if it is very much less than IDC, means IDC is what? That is up to 60 milliamp. I expect that they are all symmetrical to each other. Okay, so it is also allowing 60 milliamp. So it means that you have mostly loaded this connector, but you have not used this one. Okay, so in this case, the design, you have made it well, but you are not managing your car properly, your charging station properly. Okay, so this will only be tripped if some faults are happening. Correct? If fault happens, then only the high current will flow. Otherwise, there is no sense. But here, as you are loading it, means loading it heavily. So even if it is not in faulty condition, but there are highly chance that RCD will detect a fault. Correct? So that is why you see here that type A or F, it is very much reliable, more reliable than this. Means if even this senses that your connectors are very much loaded and it suppose detects and disconnects, however, this RDC DD will actually say you that this is not a fault, this is a highly loaded condition. So this will differentiate from a fault to highly loaded situation. And that is why this type of connector, this type of protecting devices are more reliable than RCD type B protections. However, the drawback is there that if you are connecting here this one, but you are not connecting any protecting device here, right? Because you are thinking that there are two separate protecting devices on this single connector. So overall system wise, you may see that if you are not using here the protecting devices, so straightforward what will happen, these vehicles will having the challenge, okay, or this connector will having the challenge. So what is suggestion that you should have protective devices connected to each and every connectors. Okay, each and every connectors, so that the reliability will be maintained. So I'm just skipping these things because time is very limited. It's already 3:30. Now you see surge protecting devices. These are also important thing for the protection. And again, these are implemented for all these charging requirement, because in domestic as well. If you are even planning to install your charger to be in your home area, then also you should having some arrangement for surge protecting devices. That IEC standard says that you should having a surge protecting device distance wise at least 10 meter. Okay, not less, means if you are suppose you are having a charging point, and up to 10 meter from that charging point there is no surge protecting device. This is wrong. You cannot be allowed. Okay, so that is the way of placement for these surge protecting devices. So you see here that this T2 is SPD. This is mandatory, correct? Now if you are placing it here, as you can see, this charging station distance from this is less than 10 meter, so you don't require to place a separate SPD to this charging station, correct? Because it is well understood by these protective engineers that when surge happens, if that affects your charging station, it will be saved by SPDs if that distance is less than 10 meters. Okay, so that will be taken care of either by this. Okay, no, not either. It will be protected by this because it is less than 10 meters. But if this was not there, suppose you assume that if it was not there, then what would be the problem? You see, the nearest SPD from this is this, which is greater than 10 meter. It means it is not protected. Okay, that is why you see this is mandatory for placing this one. Okay, now this one again, it is in place here because distance from here to here is greater than 10 meter. So you are placing a separate SPD on this charging station only. Okay, and of course, if you are again finds that this charging station distance is more than 10 meter from this charging station, then of course you are using another SPD on this charging station. So that is the way of placing the SPDs to protect the charging stations from the surges. Now a separate condition you see here, you may not like to place several SPDs in charging every charging stations, correct? Because you are supposing you just assume that you are located in such a place that there are very smart city and most vehicles are electric vehicles, correct? So that the charging stations requirement is also very high. In that situation, if you connect your charging stations in like in previous slide, then what happens that you may require to have the SPDs in every charging stations, okay, or even most charging stations, which is very painful. But if you connect all the charging stations through the busway and SPDs are placed not in charging stations, it is in busway, then automatically it is being protecting the subsequent charging stations. Okay, so that is the beauty of this thing. So no more SPD required here because you are already placed your SPD in the busway, because busway is a very conducting material and this can take care of the distance. Okay, so you can straightforward reduce the usage of SPDs to implement in individual charging stations. So this is again one more design. Okay, I'm not discussing this one. Okay, so now one more thing, you see that that how we understand this is only not the 10-meter distance wise, we cannot design, we cannot place these such SPDs. We should also think that what is the area under the protective range. Okay, so this is again another point, that your SPD should not be required if L less than equal to 10 meter or T-twin sub panel. This is again another thing. Okay, so when surge happens, that some voltage, very high voltage is induced in the neighboring region, right? So that should not be more than 1.25 kV. Okay, so this is again it is given, it is written in IP54 protective manual. Okay, and this should be, this is also included in the IEC standard. Now you see another parameter. You see here this dotted line, it means that under this area it is protected, the outside of this area is not protected. Okay, it means you see here that this vehicle is standing in such a area that slightly it is going outside of this. Okay, it means that it is not overall protected. So basically charging station is inside the area, correct? So that is the most important part. Charging station should be protected and not the vehicle. Okay, so suppose your charging station is placed here and your surge protecting devices are somewhere less than 10-meter distance, so that the protective SPD is protecting up to this area. So this is actually signified by this LPZ parameter. Okay, so integration, okay, these things are very basic things. I will just keep it. Okay, and this will also I will skip. These are all actually industrial designs. That is why I asked you all that if you are working in industry, it will be very beneficial to know. Okay, especially in the charging infrastructure, these designs to know. Generally in academic structure we skip these things but in practical implementation these are all very much required. So you can see here importantly the static load management system, and another will be in the dynamic load management system. Okay, so these two parameters you should keep it in mind. I will discuss in the next after few slides. Yeah, so here you can see that there are basically static load management systems which actually managing the EVs in a very standard way, we can say. Okay, it means that first point is that they are implemented mostly in autonomous mode, not in grid connected mode. Okay, static load management system. So it means that they know their own capacity. It means who are they? They are actually the charging style. It means the charging owners. Okay, you are having a charging station or multiple charging stations. Okay, in a bigger area, and you are managing it. So of course you are having your own loads. Own loads means your own home area or something else, means your own loads, and also EVs. Okay. Now, what you will want as an owner or as a businessman, you will try to make benefited as much as possible by using less power and also by charging means you want that to engage your charging stations as much as possible, correct? But the vehicle's demand in your charging station is very much fluctuating. That is why the static load management is beneficial. So when your load demand means EV's demand is less in your charging station, you may use your own charging station to have your local loads. Okay, like your battery charging or something else also. Okay, but if you are having at some time you are having a very rush of cars, then you may use your own batteries to help the charging stations, okay, and to help the requirement of the parking cars. Dynamic load management is generally being used for with the connection of grid. Okay, means dynamics, when it comes, it not only comes for the vehicle side, it also comes from the grid side. So that is why when you are connecting in a network, in a distribution network, then the distribution utility side may not allow you to fluctuate your demand so much, because that will impact on the voltage regulation of their own utility side. So what you should arrange to minimize the impact on the grid, you may have your distributed arrangement. Several type of loads you can arrange, and you may balance your demand with the time, so that the network utility will see that your demand from the network is different from time to time, but not in a faster pace. Okay, and that will improve the regulation of the system. So very precisely, I can say you that dynamic load management is useful for chargers side, charging station side, more useful in the utility side. So you may think that as an owner, I don't have any problem if my demand is being very much fluctuated, but utility will not allow you, or otherwise they will penalize you if you are the reason behind the impact on their regulations. And then AI based load management is very advanced technique. It could be useful from the utility side or charging owner side also. It means that utility also helping you to improve your performance. You may not have a sufficient reserve to balance your load fluctuations, but utility is interested to use their own infrastructure to improve charging stations performance. Okay. So here just 4 things I have identified. This is important to know: energy consumption forecast, utility side. This is completely from the utility side. Energy consumption forecast, energy production forecast, EV planning, and energy tariffs. Okay, these 4 things should be declared in a robust way to the utility. Then only this AI based load management technique can be implemented. Now you see what is the benefit of using load management system. Let's say there is no kind of load management system, and for an example, you see that load power consumption, this is your own load, okay, or if you are connecting with the utility, then it is overall load from the utility side. This is the EV power consumption from your own charging stations. Now, as an owner, you have made base of this. This is your base, correct? So you know that maximum and minimum will be inside the base. Okay. So as you can see that EV demand is very much fluctuating with time. You cannot, it is not in your hand. So the energy wastage is this one, correct? This is the energy wastage. However, if you can minimize this energy wastage, then that is good, correct? And also you see, this is actually available power not used for EV charging, because you have restricted this is base. At max, you will use this much of power. So, of course, this is actually unutilized power. It is declared. It is not actual. It is declared. Okay. So, you are declaring that this much of power, even if it is available, you will not utilize it from the grid. Okay. And how are you making it base? By looking into the peak demand from the utility side, and this is being actually decided by the utility, not the EV owner or charging stations owner. It means this base is not decided by the charging station owner. If the charging station owner is deciding to connect their own charging station to the utility grid, then grid will declare that at max this much of power you can draw from the utility. Okay, so this is the way of operation. So they will declare and you have to follow. So now you see, utility knows that this much of power cannot be used or energy cannot be used for EV charging. Now you see the beauty of load management. Now the base is actually changing. The utility is declaring the base is base will vary with time. You see, this is very much following their utility load, correct? So that is the beauty of the load management. Okay, dynamic value. So you see here that EV power consumption is also increased. Previously, base was like this, here, somewhere here, correct? So the EV power consumption was also restricted. Now, as the base is being improved, so the charging station or the utility is giving more flexibility to the charging station owner to increase their own EV power consumption, correct? So obviously in this regard, the charging station owner will be benefited. Okay, it is not just a benefit of utility, it is mostly beneficial for the charging station owners. Now you see that this is again another scenario. So additional power available for EV charging with local energy production. You see that this is the local energy which is being produced by utility, but the energy source is connected locally with the charging stations. Okay, let's say these are all solar panels. In the daytime, it is being generating much more energy. So again, this is being tracked. Okay, this is being tracked when they are determining the base load. You can see. So it is far more improved from the previous stage. Okay, so automatically the EV power consumption will also increase. So in this way, we can think that if charging stations are connected with the grid, it's not the benefit of utility, it's also benefit of charging owners. Okay, they can use more and more power if the utility provides them the flexibility. So these things are actually different. So this is a part of the forecasting. How could we forecast the load? How could we forecast the generations if we are having the PVs and batteries, also EV chargers? Okay. Okay. So now I will try to end up my talk because I need few more time to discuss with the audiences if they are having any question. So this is the one curve. This is actually showing this cost versus amount of preventive maintenance. So if any infrastructure is being made, obviously there is requirement of some repairment or preventive arrangement, correct? So preventive and corrective, these two things are completely different. So preventive maintenance, if you investing more money in the preventive maintenance, of course, there is a less chance to make it failure. Okay, means there is a less chance of corrective maintenance. It means that you are having your own charging infrastructure. You are having a lot of protective devices, as earlier I told you. So it means you are having a preventive maintenance cost very high, so that your charging stations will never fail. So this means you are having no chance of having a corrective maintenance. So obviously you can reduce the budget of corrective maintenance requirement. So that is there actually. If you increase the investment on preventive maintenance, of course you can reduce the investment on corrective maintenance. However, the overall cost, means overall investment or overall cost, depends on the summation of these two, correct? So basically this is the curve which adds this curve and this curve, and surprisingly you will find that one range, or this is a break even point, you can see that at this point both the cost is exactly equal to each other. However, you cannot be you cannot guarantee that always you can maintain at this point, right? So in the real time you should have slightly here and there. That is why this is the range of operation. You, as an owner, you will always find what is the cost versus corrective maintenance curve for your own charging stations, and also what is the preventive maintenance cost, okay, curve. Once you will know this, you can easily find the operating range, operating maintenance zone. So there are different type of connections for charging stations. So vehicle to grid, it could be unidirectional, it could be bidirectional. Okay, it means V2G is grid to vehicle is also allowed. Okay, sorry, vehicle to grid is also allowed, but V1G, in case of V1G, vehicle to grid is not allowed, only grid to vehicle is allowed. Okay. So that's all from my side. So if you are having any question, we may discuss. Hello.
Thank you, sir. So, dear participants, if you have any doubts, you can ask. Unmute your speak. Unmute your mic and ask the question. Sir, in the chat box, there is one question.
Okay, in the chat box, is there any question?
Are we using wireless EV chargers in India?
Sorry, can you repeat?
Are we using wireless EV chargers in India?
No, presently not.
Any question? Any question from participants? I think no question. Thank you, sir. It is very informative presentation. I am sure you enhanced you enhanced the research skills of the participants in the area of electric vehicle charging station, EV, PV charging stations. You also provided very useful content about electric power station, electric vehicle connectors, EV charging modes, charging time, smart charging. Once again, thank you for accepting our invitation and spending your most valuable time in our FDP. Thank you,
Okay,
sir. So some of the participants requested me share your PPT slides.
sure. I will share to you, but maybe you can share me your email ID. Okay, so I will send this PPT to you and you can circulate it.
Okay, sir. Thank you, sir.
Okay, and for the participants, I can tell you that though my talk is regarding the electric vehicles, but I generally prefer to work in power systems. So if anyone, any participant want to contact me in this regard for research purpose, any such requirement or any doubt, anything, they can ask me by emailing in my professional email ID. So that is in my website, they may search. And also if the audiences are willing to have PhD or even MTech by research, they may, of course, my means opportunity is always open from my side. Okay, they may contact me, but my area of research is mostly towards the power system based. Okay, it's not power electronics, but in power system based. So that is for audiences. Okay. So thank you for giving me such a good opportunity to interact with the researchers.
Any doubt? Okay, sir. Thank you.
Okay, thank you. So I'm leaving this meeting.
Okay, sir. You can leave the session. నా కాంటాక్ట్ ఉన్నాడు కదా మీకు సార్
10 రోజులు నా మీద